For hundreds of years, there's been this one math problem, a real monster, lurking right under our noses. It was a challenge so deep, so fundamental, that for 2 full centuries, the smartest people in the world all agreed on one thing. It was absolutely impossible to solve.
But what if that impossible problem wasn't? What if a 200-year-old mathematical law was, well, just plain wrong? Today, let's dive into how a bedrock certainty of mathematics is facing a shocking new challenge.
Okay, so let's get into it. The problem we're talking about is all about solving something called high-degree polynomial equations. I know, that sounds super intimidating, but the basic idea is actually something you've definitely seen before.
Remember the good old quadratic formula from high school? The one that gives you a perfect, clean answer for equations like ax squared plus bx plus c equals 0? Well, that's great for when your variable is squared. But what happens when you kick it up a notch? To the 3rd power, the 4th, or even the 5th? Suddenly, that nice, neat formula just vanishes. The problem doesn't just get harder, it totally explodes in complexity. For centuries, the Holy Grail was to find a similar magic formula for these bigger equations, an exact, perfect solution, not just a close enough guess. And that difference between close enough and perfect is a really big deal. A great way to think about it is with the number pi. We often just write it out as 3.14159 and so on. But that's just an approximation, right? It gets us in the ballpark. The real pi, the symbol pi itself, represents the perfect exact value. It's the absolute truth of it. And that's what mathematicians were after. They weren't looking for the 3.14 version of these equations. They were hunting for the pi.
But for a really long time, it felt like they were chasing a ghost. Eventually, they hit a wall, a hard limit that seemed to define the absolute boundaries of math for the next 200 years.
And this timeline here really tells the story. Back in the 1500s, things were looking good. Mathematicians cracked the code for 3rd and 4th degree equations. Awesome. But then, nothing. Progress just slammed to a halt. For almost 300 years, the 5th degree equation, they call it the quintic, just laughed at every single attempt. Finally, in 1824, a guy named Niels Henrik Abel proved it. He proved it was impossible to solve using the standard tools, addition, subtraction, multiplication, division, and taking roots. A few years later, Galois theory came along and basically double underlined why it was impossible. And that was it. Case closed. Officially impossible.
So yeah, for 200 years, Abel's theorem wasn't just a theory, it was the law. But there's a great saying that limits exist only until they are surpassed. And that, my friends, is where our story takes a very sharp turn.
Which brings us to the person challenging this 2-century-old belief, Professor Murad Sultan Ezouidi and his new framework, now known as Ezouidi's theorem.
And let me tell you, the claim he's making is absolutely audacious. He's not just talking about solving that impossible 5th degree equation. No. He's claiming a complete, exact, symbolic solution for a polynomial of the 20th degree. This isn't just pushing the boundaries a little bit, this is a direct challenge to the history books.
So you've got to be asking, how could this even be possible? To get our heads around it, we first need to understand why the old ways failed, and then see what this new theorem claims to do so differently.
Look, Abel's proof was genius, no doubt about it. But here's the catch. It only proved it was impossible using a specific set of tools, what we call radicals. Those tools just weren't sophisticated enough to handle the incredibly complex inner patterns, or symmetries, of these higher degree equations. I mean, the number of moving parts would just explode into millions of terms. Any of the old methods would get completely overwhelmed, forcing mathematicians to just give up and settle for a close enough estimate.
And Professor Ezouidi puts it perfectly. He says the limitation isn't in the equation itself, but in the tool set. It's like mathematicians were trying to pick a highly advanced digital lock with a simple key. The problem wasn't the lock, it was the key.
This table here really shows you the massive shift in thinking we're talking about. On one side, you have the classical methods from Abel and Galois. Anything above the 4th degree is impossible, you have to rely on approximations, and you just have to accept that there are limits. But on the other side, you have Ezouidi's theorem, claiming exact, 100% verifiable symbolic solutions and philosophically just rejecting the idea that there are any limits at all. It's a total game changer.
Okay, so how does it actually work in simple terms? Well, instead of trying to wrestle with all that complexity at once, the new theorem is way smarter. It uses a recursive process to break the problem down piece by piece. It finds these hidden patterns within the equation's own DNA, and then it uses this totally new technique called X-root extraction. Basically, it kind of coaxes the equation into revealing its own perfect answers without ever having to guess or approximate.
If this thing is real, the implications are just staggering. Seriously, if this theorem holds up to peer review, it's doing way more than just solving a crazy hard math problem. Because this isn't just some clever trick that only works for the 20th degree equation. No, what's being proposed is a universal formula, a whole new algebraic framework that could work for polynomials of any degree. That's the part that could literally rewrite the textbooks.
And that brings us back to the biggest idea of all. This isn't just about finding an answer. It's about fundamentally changing what we even consider to be answerable. It redefines the very meaning of solvable.
So we're left with a pretty wild question, one that would have been laughed at not long ago. Is Abel's theorem not the final word, but a milestone that we've now passed? Look, it's an incredibly bold claim, and you can bet the entire mathematical community is going to put it through its paces. But it's a powerful reminder that even in a field as solid as mathematics, the limits we believe in today might just be the starting lines of tomorrow.